All right. So hello again and good afternoon. So let me just check if everybody is already here. So just give me thumbs up. Right. So it seems that half of you were already here. More than half of you, like 70% maybe. So there are others who are not responding anyway. So I hope they'll be back right away. All right. So let's answer this one now. The example on the weighted mean. So many colleges use the 4-point grading system. So in my case, I've never experienced this one. Okay. My school before, elementary, high school, even of course in UCD, we don't use this one. Okay. So I've never experienced this kind of, a 4-point grading system. So anyone here who, who've experienced maybe this kind of grading system like uno, dos, you're saying uno is I don't know, maybe the passing grade. So as long as you will get uno, then it's right, okay. And then cuatro, I don't know, but it seems like this one is the opposite, since uno in other schools are the 95 or the like the high score, the high grade, right?
Yes,
Am I
sir.
correct with that one? But in here, uno is like maybe 75, and then dos is maybe 80, and so on and so forth. And then if you have a grade of 8, then that one is like maybe 95. Okay. Anyway, so a student's grade point average or GPA is calculated as a weighted mean, okay, where the student's grade in each course is given a weight equal to the number of units or credits of that course is worth. So the question here is find the weighted mean. So the table below shows the LUN's fall semester course grades. So use the weighted mean formula to find the LUN's GPA for the fall semester. So here is the course, and then here is the corresponding course grade, and then the course units. So in this school, English subject is a total of 4 units. History is history, chemistry is history, and then algebra is 4. So it says here that the weight this is one is coming from the course units itself. So the higher the unit of that course, the more that it's more important for you to have a high grade on that one. Okay, so in here, English and algebra is a lot, better, well, at least 1 point better with the history and then the chemistry. Okay, and then here are the corresponding course grade of the LUN. Okay, for the English, I was able to get a B grade. Okay, and then we have here history, which is A, chemistry is D, and then algebra is C. So I don't know. In some schools, they even have like A plus, A minus, B plus, B minus, etc. etc. Okay. So in here, let's just focus with the letter itself, which is just A, B, C, and then D, and even F, of course, for the failing grade. So here is the computation. So this is the explanation on the B is worth 3 points and so on and so forth. But yeah, all you need to do is use this formula, okay, and then you will have this one as your solution. So for the weighted mean, we have 3 times 4 because letter B is equal to 3, and then 4 times 3 because A is equal to 4, okay, and then it's equal to 3 units, plus 1 times 3 because he has a grade of D, okay, on that chemistry, and then 2 times 4 for the algebra because he has a grade of C, okay, and then multiply to the course units. And then you can just divide this one with the total counts of weights that we have in here. So we have 4, 3, 3, and then 4. So 4 plus 4 is 8, plus 6 is equal to 40. Okay, so here are the data that we have 3, 4, 1, and 2, which came from this course grade, and then followed by the course units or the weight itself. So just do the math, and then you will get 2.5 as your weighted mean. And I don't know, maybe this one is equal to C plus or B minus. So the Lun's GPA for the full semester is 2.5. All right. So just let me know once you're already good with this one, once you fully understand everything. So we can now proceed to the next slide. Okay, very good. One, two, three.
Okay po, sir.
Okay, very good. 1, 2, 3, 4, 5, 6. Like 6 out of 27. Okay, or 9 or 10 out of 27. Still not good since I at least need 13. You know, if you guys were able to convince me that most of you were able to get this one, then we can now proceed to the next one. Because it's a bad news if, you didn't get this part. So I want you guys to, to learn, to understand everything, not learn everything because you will learn everything. Just be familiar, right? Be familiar. So there are times that, this might be helpful in your job, maybe. Anyway, so that's it for the weighted mean. So let's now proceed to the frequency distribution. So in here, this is the like the reality. Okay, so this is what you do first before you can have this kinds of data. So this one is only for one person. But what if you have uh 10 students, 20 students? So you will have a table which is called the raw data. So raw data is, from the name itself. So it is a data that have not been organized or manipulated in any manner are called raw data. Okay, so let's just have this example. So this is already a lot actually, like 5, 10, 15, 20, 25, 30, 35. Yeah, we have 40 datas in this table. So a large collection of raw data may not provide much readily observable information. Well, maybe you can get the mode of this one. Okay, I think maybe the mode of this one is 1. Okay, but after that you cannot do anything anymore. Okay, because you have to look, if you're going to get the median, so you're going to arrange this one. If you're going to get the mean, you also need to add everything and then count how many data. So that's quite, you know uh, a pain in the ass to do that one. So in here, uh let me introduce to you guys the frequency distribution. So this is a table, list observed events and the frequency occurrence of each observed event is often used organized raw data. So for instance, consider the following table, which is the list of number of laptop computers owned by families in each of 40 homes in a subdivision. So from this raw data, okay, to make your life easier, okay, so we have to make this one or put this one into a frequency distribution. So this one is the example of a frequency distribution. So here we have the observed event number of laptop computers, which let's just call this one as your X. And then we have here a frequency number of household. Let's just see, this is the frequency, okay, on how many times it appears on this first column, okay, with X laptop computers. All right. So in here we have 0 to 7. Okay, and then we have random numbers here, which the count of datas of those x right here are the numbers right here. So this row indicates that there are 14 households with 2 laptop computers. And then we have one. Okay, so my answer is incorrect. So see, the median in here, the mode in here is not 1, but it's 2 because 2 appeared more, than the 1. So okay. So yeah. So for 0 computers, we have 5 household for that one. Okay, for 1 computer, we have 12 household for that one. And then we have 2 for 14, 3 for 3, 4 for 2, and so on and so forth. Okay. So the formula for a weighted mean can be used to find the mean of the data in a frequency distribution. So the only change is that the weights like W1, W2, and so on and so forth are replaced with frequencies, which is f1, f2, and so on and so forth. Okay, so this procedure is illustrated in the next example. Okay, but yeah, so are we clear so far regarding with this frequency distribution? There is actually one thing that
Yes, sir.
is missing. So as you guys can see right here, if you guys are going to observe this one, there is no 6 in here, right? But we still included that one. And as you guys can see, we've just put here 0. So the best way for you to, to arrange this one or to make a frequency distribution is find the lowest and then the highest. So if the incrementation value is not that far, so you can just count everything, like say from 0 up to the highest, which is 7. So you can just count from 0 to 7, and then you can just check this one by one. So 0 has a count of uh, 1, 2, 3, 4, and then 5. So that's why we put here 5. Okay, and then 1 is now, of course, discount how many ones we have in here. 2, discount how many 2 we have in here until you reach the value of your latest number in here. All right. So that is the quickest way, instead of getting all of the individual datas. So you can just do this one, like ranging from 0 to 7. Just put here 0 for the 6. Okay. So in here, we have to find the mean of data displayed in a frequency distribution. So again, we have this data right here, and then this data right here, so we haven't changed anything. And then this is the solution. So instead of weight, okay, or W for this F right here, so just replace this one into F, since that is the one that we have used. They call this one frequency, okay, instead of weight. Okay, and then instead of summation of W, okay, so this one now is the summation of F. So you could say that this one is the same with the weighted mean. It's just that when we see frequency distribution, this one came from a raw data. So those are the differences and why we have to use F instead of weight. Okay, so just do the math. Okay, so 0 times 5, 1 times 12, 2 times 14, and so on and so forth. And then divided by the total of frequencies that we have here, which is 40. And then you will get 1.975. So there is an average of, let's say, 2 laptops per household. Okay, so I've just rounded this one up since there is no 0.975 laptop. Okay, so it should be a whole number. Let's just say 2 laptops all in all. So are we clear with this one?
Yes, sir.
Okay po, sir.
All right, it's good then. So let's now proceed to the measures of dispersion. So let me just differentiate the difference between the measures of central tendency and then the measures of dispersion. So both of them is the basics or the fundamentals of statistics. So measures of central tendency is central or the center. So let's just say measures of central tendency is equal to average. That's it. Okay, and then measures of dispersion is the it's also the same with average. However, this one is like solving for the error, okay, or the yeah, the deviation itself. So this is the main definition of dispersion. Okay, so in here, the lower the dispersion, okay, or the lower the deviation, the better. Okay, so you will see later on what is the use of those, the range, standard deviation, and then the variance. Anyway, let's proceed with the range first. So in the preceding section, we introduced 3 types of average values for a data set: the mean, the median, the mode. So some characteristics of a set of data may not be evident from an examination of averages. So even though we have those 3 types of averages, so there's a chance that we are still missing something. okay, we can still miss important computations. Like for instance, consider a soft drink dispensing machine that should dispense 8 ounces of your selection into a cup. So we have here the table below shows the data for two of these machines. For the machine one, we have this one, and then for the machine two, we have this. So let's start with the machine one first. So in here we have, let's say it dispense first 9.52 ounce. So uh, it's more than what we expected. So it should be 8 ounce only. The second one is 6.31. So it is now, lacking uh, some amount of soda on that can or on that bottle. The third one is 10.07, so it's more than the average again. So it's more than the expected dispense amount. Okay, and then the next one is 5.81, so we're lacking again. 8.15 is the best one. Okay, I think this is the closest for your 8 ounce. Now, if you guys are going to get the average of those, okay, so you will get a mean of 8.0. So it's like nothing happened, like, okay, we're able to distribute an average of 8.0 for those 5 bottles or for those 5 cups. But if you guys are going to check on this one, some are lacking and then some are just too much. Okay, well, if I'm the customer, so I'm happy if it's more than what I paid for, right? But if you receive this, kind of product, let's say we have 6.41 ounce instead of 8 ounce, so you're not going to start to uh, like maybe what do you call this one? Parang aawayin mo yung tindera. Okay, hindi mo naman sisisihin mismo yung company. But yeah, you're going to ask the store itself, and then me I get a new one. The one that has an exact amount of soda. Okay, which is 8 ounce. So yeah, so we have two defective sodas in here. So what will happen on those two defective sodas? So of course it will put as a BO or bad order. So mga nag-grocery dyan, alam niyo siguro yung BO. So of course, the company itself will change, okay, or will get those BOs and then will be changed by a good product. Okay, like the correct size of, I mean the amount of soda on that bottle. Okay, so malulugi kayo. Okay, so meaning this machine one is defective. Okay, so that is the moral lesson of this machine one. Even though we have an average of 8.0, but if you guys are going to take a look on each of those data, so some are not good or some are defective. But for the machine 2, okay, we have 8.01, 7.99, 7.95, 8.03, and then 8.02. So with this, we cannot argue anymore, okay, with the or with these machines. It's like working perfectly. Okay, so there is actually no perfect machine, so that's why we have some, a little bit of deviation right here, which is 0.01. Still 0.01, still lacking 0.01, though the customer won't see that one anymore. Okay, and then this one is lacking 0.05. Again, it's super close. Okay, it's not that obvious. 8.03, so the customer is a little bit more happier since it's more than 0.03 ounce. And then we have here 8.02 ounce. Okay, this is super close with the 8 ounce. And then again, if you guys are going to get the average of this one is still 8.0. Okay, but if you guys are going to check the uh, how it dispenses per cup or per bottle, so this one is the perfect machine. Okay, now if we're going to talk about the range from this defective to a working or non-defective machine. So where is that one? Okay, so here's the summary. I won't be reading everything anymore. So machine 1 is inconsistent, and then machine 2 is consistent. So for the range of a set of data values is the difference between the greatest data value and then the least data value. So here the same like idea. Okay, the lesser the range, the better. Okay, so if we are going to get the range of this one, so latest to highest of machine number 1, so the highest rather, the highest is 10.07, and then the lowest is 5.85. So just do the math, and then it will give us a result of 4.22 ohms. Okay, so meaning this kind of range uh, is a little bit alarming already, since we have this kind of error, okay, which is 4.22 ohms. But okay, so there is no machine 2. But for the machine 2, if you guys are going to get the highest and lowest, probably it's just a point something. So having a range of maybe 1 and below is acceptable. Okay, but having a range of 4 is not acceptable anymore. Okay, so that is how we check our how that machine performs. Okay, with the use of the range. So are we clear so far regarding with the range? Okay, so in here, again, the idea of measures of dispersion is the lower the value, the better. Okay, all right, so let's now proceed to the standard deviation. So in here, the range of a set of data is easy to compute, okay, but it can be deceiving. Okay, so yeah, because we are just considering the highest and then the lowest data, okay, which is still not perfect when it comes to solving the error, okay, or the ineffectiveness of that machine. So the range is a measure that depends only on two most extreme values, and as such, it is very sensitive. So a measure of dispersion that is less sensitive to extreme values is the standard deviation. Okay, so they made another way of checking the data, in which even though we've just changed one data, it will affect everything. Unlike in the range, even though we've changed the some of the data in the middle, it won't make a big change. Okay, well, unless you change the most extreme data and then the most lowest data. So the standard deviation of a set of numerical data makes use of the amount by which each individual data value deviates from the mean of itself. Okay, so this deviation is represented by x minus x bar. So this one is positive when the data value x is greater than the mean. Well, it's already common sense. And then x minus x bar is of course negative if the other way around is higher. And then if they are just the same, then of course you will get 0, okay, or the same. Okay, and in here the sum of all the divisions of this x minus x bar is 0 for all sets of data. So if it's not 0, then your one of your computation is probably incorrect. So this is one way, or the first step for you to check if you made the correct computation or no. So this is shown on the right side table for the machine 2. So we have here the the raw data itself, the first 5, or how it dispense on the battle or the can itself. And then here is the computation for the x minus x bar. So x bar right here is the mean of this one, okay, which is of course 0, okay. And then x right here is just the individual data. So 8.01 minus 8 is 0.01, 7.99 minus 8 is negative 0.01, and so on and so forth. And then if you guys are going to add those, if you're going to add everything, it should be 0. Okay. So in here, you can already check, okay, this one individually. Okay, like this one has a deviation of 0.01, so it's almost perfect, meaning this one is working perfectly. So the same as this one, almost perfect. This one is quite far already, 0.05, but it's not that far. Okay, maybe if this one is 0.5 or 0.50, then you might need some adjustment to this machine. But 0.05 is not that much. 0.03 is still good, and then 0.02 is also good. So if you guys are going to do this one the same, with the machine one, so you will get a 4 point something, 3 point something. Okay, and so on and so forth. So you'll get a higher deviation on that machine one. Anyway, so that's it for the standard deviation. So we have here the formula, okay, like another step. So it didn't end on this part. So this is just the first step. So we have here the standard deviations for populations and then samples. So for the population, we have this one, and then for the sample, we have this one. So both of them are the same, solving its standard deviation. However, if it's population only, so all you need to do is divide that one by n. Okay, but if it's sample, okay, all you need to do is divide this one by n minus one. So those are their main differences. Okay, so if it's population, just divide that one the count of data that we have. But if it's a sample, divide that one by the count of data that we have minus one. Okay, and then the symbol for population is this one, and the symbol for sample is s. Okay, and in here, as I guess can see, since we're talking about population, so we should get the symbol of the mean of population, which is mu. Okay, and then for the sample, so the mean of this sample is x bar. Okay, so just do take note of those differences, mu and then x bar, and then n minus 1, and then of course their symbol. All right, so here is now the complete procedure on how to solve the standard deviation of the certain data. So we have 5 steps for this one. So the first one is determine the mean of the n numbers. Second is for each number, calculate the deviation difference between the number and the mean of the numbers. The third one is calculate the square of each deviation and find the sum of these square deviations. The fourth one is if the data is a population, then divide the sum by n. And then if the data is sample, then divide the sum by n minus 1. And then lastly, find the square root of the quotient in step number 4. Now, supposedly, of course, you guys will be memorizing this one if we are only in face-to-face method. Okay, but since we are in ODL, so this will become an open notes. So you guys don't need to memorize this one, just familiarize maybe. Okay, so let's have an example for this one. So find the standard deviation of this sample. So following numbers were obtained by sampling a population. So this one now is obvious. So this one is a sample because this one were obtained by sampling a certain population. And then these are the numbers that he or she have chosen. Okay, 2, 4, 7, 12, and 15. So find the standard deviation of the sample. So step number 1, find the mean. So all you need to do is add everything and then divide how many counts of data that we have. So 40 divided by 5 is equal to 8. Step number 2, for each number, calculate the deviation between the number and the mean. So 2 minus 8 is negative 6, 4 minus 8 is negative 4, and so on and so forth. The third one, I mean, it's still part of step 2, okay, you have to add those numbers. So negative 6 plus negative 4 plus negative 1 plus 4 plus 7, it should be equal to 0. Again, if it's not equal to 0, then there is something wrong with your computation. Okay. All right, so the third step, calculate the square of each division in step number 2. So in here, just square this one. Negative 6 squared is 36. Negative 4 squared is 16. And so on and so forth. So all you need to do is square those values. And then get the sum of those. Then we will get 113 as the sum of the squared division. And then step number 4, because we have a sample, so this is now where we need to use this s right here. Okay, s is equal to summation of x minus x bar squared divided by n minus 1. So of course we have to use that formula. Okay, oops, I think I wasn't able to show the computation of that one, but yeah, we have to divide that one by n minus 1. Okay, So in here we have, where is that one? Do I have the computation? So this is the numerator part wherein, after getting uh, or after solving everything on the summation x minus x bar, okay, will give us a result of 118, and then just divide this 1 by 4, which is now equal to 29.5. Or, okay, or you can just simply get this one. So I think that is the reason why, I just remember, I think that is the reason why I didn't show the computation for this one. Because, after solving this one, you are like already done with step number 1 to step number 4. Okay. As you guys can see, we've got a 118, and then divided by 4, which is the n minus 1 right here. And then we've got a result of 29.5. And then lastly, step 5, the standard deviation of the sample is s is equal to square root of 29.5. Okay, so this is now the standard deviation, which is 5.43. So it's quite high. Okay, so if this one is only maybe 1 or below, then I think that's already a passing score for a written machine. Okay, so are we clear with this one so far? So before, I required my students to do the two-step, okay, wherein they are going to follow this one, step 5, and then they are going to follow this one to solve for the standard deviation. So yeah, that's what I did before. But in here, you're free to use any of those two since they are just the same, okay? As long as I will be able to get your correct answer with the standard deviation. Okay, so regardless of your ways of solving that one, then it's okay. Okay, as long as your answer is correct. Anyway, so we have another example here wherein, of course, we have to use standard deviation, okay, or we have to identify the standard deviation of this one. Okay, so again, you can use this is step 1 to step 5. Okay, but in here, I think I've shown the other way around, which is the the one-shot formula. This one right here. So we have three companies right here. So in here, they are testing the company that produces batteries that are most consistent. Okay, with regard to their life expectancy. So consumer group tested a sample of 8 size T batteries from each three companies, which is Ever So Bright, Dependable, and then Beacon. The results of this test are shown in the following table. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 tests for each company. So according to this test, which company produces batteries for which the values representing hours of constant use have the smallest standard deviation? So again, in here, the smaller the standard deviation, the better. So all you need to do is apply the formula that were given to you, and then just substitute the given values, and then you will get those results. So we have here for the Ever So Bright, which is equal to 1.328 hours. And then we have the Dependable, which is 0.719 hours. And then we have here the Beacon, which is 0.877 hours. Okay, and again, as usual, the smaller value, the better. So all you need to do is compare those three companies. So just find the lower standard deviation, or the lowest rather. So in here, Dependable have the smallest standard deviation. So according to these results, the Dependable company produces the most consistent batteries with regard to life expectancy under constant use. Okay. So of course, you won't be able to see that one if you only have this raw data. So unless you're going to use the formula, and then you'll be able to identify which companies produces the most consistent, uh, long-lasting battery. Okay. So when it comes to checking or verifying this one, so just uh, check this one once our meeting is over. Okay. So we still have 2 minutes and 40 seconds. So I think that is not enough since I have an additional announcement. So I will cut our meeting here for now, and then we'll just continue the rest on the part 3. Okay. So goodbye for now, and then see you guys later on the part 3.
Bye, sir.
Goodbye.